So tonight's video is going to be about factoring, and we'll do a really quick review of the factoring we've done earlier and then extend that just a little bit to factor some polynomials that are slightly more complicated. So here are three examples. The first one is just a normal trinomial where we're looking for numbers that are going to add to 9 and multiply to negative 22. So we can do that with x plus 11 and x minus 2. The second one is the difference of squares. We've got x minus 10 times x plus 10. And the third one is just greatest common factor, so we get that this is x squared times quantity x squared plus 3. So hopefully those three examples are pretty quick and easy for us because we'll be relying on some of this as we look at some of the more complicated examples. So as we look at this slightly more complicated example, we should always make sure that we're checking for a greatest common factor before we do anything else. Now, the greatest common factor here is 1, so we're not going to do anything with the greatest common factor. We should notice that this one looks an awful lot like x squared plus 3x minus 18. And we could factor x squared plus 3x minus 18 as x plus 6 times x minus 3. Turns out we can actually do the same thing up here. We're just going to factor this as x squared plus 6 times x squared minus 3. And we can multiply out and check that that works. We get x squared times x squared is x to the 4th minus 3x plus 6x minus, I'm sorry, those should be x squareds, minus 18. And that gives us x to the 4th plus 3x squared minus 18. So it does work out. So let's take a look at another similar example. So we'll take a look at this example here, 2x cubed minus 10x to the 5th minus 72x squared. And what is that we do first with these? I'm glad you mentioned it. We're going to take out the greatest common factor, which is going to be 2x squared, and then that will be times x to the 6th minus 5x to the 3rd minus 36. Now again, this in here is a trinomial that we could factor. Again, if it looked like x squared minus 5x minus 36, we could pretty easily factor that as x minus 9 times x plus 4. And we're going to do pretty much the same thing up here, except that we're actually, instead of x, we're going to use an x cubed, because then if we square x cubed, we get x to the 6th. So this up above can actually factor as 2x squared times x cubed minus 9 times x cubed plus 4. And here we are factored. There's nothing more that we can do with either of these. And let's take a look at one more example. So here we'll try to factor x to the 4th minus x squared minus 12. And at this point, yes, it's looking pretty much like x squared minus x minus 12. So we should know that this is going to factor as x squared minus 4 times x squared plus 3. But this time we're not done. We've actually got a difference of squares right here. So we can say that this is going to be x minus 2 times x plus 2. Then times the x squared plus 3. So in doing this type of factoring problem, we do need to look out for the difference of squares going on here after we've done that first round of factoring. So please do be careful of that. And you know what, let's just go ahead and do one more. This here we have is simply difference of squares. So just like we would have done before, we would have said, okay, this is x squared minus 4 times x squared plus 4. Again, just looking out for the fact that we've again got a difference of squares here that I can factor again as x plus 2 times x minus 2 times x squared plus 4. Again, nothing I can do with the x squared plus 4. So as you're working through these problems, just keep an eye out for the stuff that you've seen before. Keep an eye out for difference of squares, keep an eye out for greatest common factors. Always start by looking for the greatest common factor. And then just any time that you see something along the lines of, let's say, x to the 12th minus x to the 6th minus 56, say, when this power is twice that power and we've got a constant here, we should be thinking that, hey, maybe I can factor this as an x to the 6th plus something and x to the 6th minus something. And it turns out those numbers in this case are a minus 8 and a plus 7. So we will take a look at a couple problems for you to prepare for class tomorrow. So for class tomorrow, please factor the following 3 polynomials completely. When I say completely, I mean if you get partway through and you find a difference of squares, go ahead and factor that difference of squares. Anything that you can possibly factor in these, please do so, and I will see you tomorrow.